Welcome back. Today we're going to be working on solving two-step equations. There's also going to be some that are multi-step, so a little bit more than 2 steps. So these are notes 13. And here we go. Solving two-step equations is just like solving one-step equations, but with an additional step, maybe 2. Our goal is still to isolate the variable term by using inverse operations and getting the variable on one side of the equal sign. To help us keep organized, we'll still draw that line down the middle of our equal sign and undo order of operations. So to see what we need to do first, what we're going to do and use as a tool is we're going to place our finger over the variable term. So in this first example, our variable term is 2m. So go ahead and put your finger over the 2m. And what you'll see is what's remaining on that same side is positive 1. So our first step would be to undo positive 1 with an inverse operation and subtract 1 from both sides. Once we do that, the 2m will come down into the next step. 7 minus 1 is 6, and then we'll divide by 2. It ends up being a one-step equation, and we solve to get our answer. I'm just going to switch pens here for a second. All right. So let's try another one here. Example 2. We're going to put our line down our equal sign, cover up the variable term. So that's our variable term. What's the inverse of negative 4? Plus 4. So we're going to add that to both sides. So that 3m does exist, or the 3a rather, so it's going to come down. Our additive inverse is simplified to 0. The equal sign stays on the line. Different sign, subtract, keep the sign of the higher number. And then we're back to one-step equations where we divide by the coefficient, and we get our solution of a equals negative 4. Now to check this, we would just take our original and substitute. So 3 times negative 4 minus 4 equals negative 16. Well, when I multiply, I have negative 12 minus 4. Is negative 12 minus 4 negative 16? Same sign, add and keep the sign. It is, so our solution of a equals negative 4 is correct. Let's try a few more. We're going to skip to example 4, and then you're going to try example 3. So what do you think we need to do first in example 4 before we use inverse operations? Did you say to distribute? You'd be right. So 3 times h is 3h. 3 times negative 4 is minus 12. Equal sign stays on the line, and we bring down the 9. Cover up the variable term. Use an inverse operation to get rid of that constant. So now your variable term comes down, equal sign stays on the line, 9 plus 12 is 21. And finally, divide by the coefficient. So h equals 7. You go back and solve number 3. All right. Let's take a look at example 5. So on example 5, we have our line down our equal sign. And nothing changes just because we have decimals. Cover up the variable term. What do we have to get rid of? The constant, negative 1 and 2/10. So the inverse, we're going to add 1 and 2/10 to both sides. 6 plus 1 and 2/10 is 7 and 2/10. Equal sign stays on the line. Our additive inverses cancel out, and our variable term comes down. We'll divide by our coefficient because we want that coefficient to have or the variable to have a coefficient of positive 1. So 1i, that looks like li, but it's a 1. We'll divide by negative 3 and 6/10. Now, as a reminder here, what do we need to make the divisor? Exactly, a whole number. So we need to multiply it by 10. So we multiply the dividend and the divisor by 10. And we get an answer of negative 2 equals I. Good job. Right? If you don't remember, we would have the divisor and the dividend. What do you think we should do first on example 6? Exactly, we have like terms this time, so we always want to simplify like terms before we use inverse operations. So what's 3s minus 8s? Negative 5s, exactly. Once again, divide by our coefficient, and we will have our solution. Let's keep working. Take a look at example 7. What do you think the first step is here? Combine like terms, exactly. Which terms are the like terms? Is it 4, 3, and -9? It's not, because that -9 is on the other side of the equal sign, so we don't want to combine it with the other constants, just the ones on the same side. So 4 and 3 is 7. Bring down the variable term, and now we're ready to solve. Cover up that variable term, use an inverse operation to get rid of the constant. Now your variable term comes down. Be careful to keep that sign precise. Same sign here, add and keep the sign. Divide by your coefficient. And so F equals 8. You try example 8. Remember to combine like terms first. Number 9. Again, we're just starting with combining like terms with decimals this time. So we have 1 and 3/10 n minus 2 and 1/10 n. Different sign, subtract, keep the sign of the higher number. Remember, when we're subtracting decimals, put the bigger absolute value on top. Keep the sign of the higher number. So we have -8/10 n equals -8. Now what? Right. Divide by -8/10. Divide by -8/10. Negative divided by negative is a 1, so we have our n. Reminder that divisor has to be a whole number, so we have to multiply it by 10. So we have -80 divided by -8. What does that get us as our solution? 10 equals n. Good job. All right. Example 10 looks a little bit complex, but we're just going to employ all the steps that we've seen already. So, line down our equal sign. First thing again, always have to get rid of the parentheses first. So we're going to distribute first. Let's make a quick note. Distribute first. And then we're going to combine like terms. And then finally, we'll use inverse operations. Those are always the steps. So first, distribute. 2 times -4x is -8x. 2 times 1 is 2. Then everything else just comes down. Next step, combine like terms. -8x, positive 1x, different signs, subtract, keep the sign of the higher number. And then our constants, positive 2 and -5 is -3 equals 4. And now we're back to it being a two-step equation. So distribute, combine like terms, and then cover up the variable term, use inverse operations to remove the constant, and balance the equation. Bring down the variable term down to a one-step equation, divide by that coefficient, and x equals -1. How are you doing so far? Great. Let's try a few more now with fractions. So, example 11a, line down your equal sign. Cover up that variable term. The inverse is +1/2, so we'll add that to both sides. Our variable term comes down. And then we have common denominators, which makes it nice. Different sign, subtract, keep the sign of the higher number. And then we are actually going to divide that out, so we have easier work for us. Now, what's happening between the x and the 8? Division. So the inverse would be to multiply. Very good. So our 8's divide out, and we get x equals -24. Now, that's using inverse operations. There's another way you can do work in solving equations by eliminating fractions up front. Some people like this way better and some people don't. So I'm going to show it to you and then you're going to choose what's most efficient and best for you. Because notice that example 11b and 11a are exactly the same. So If you notice here, we have three different fractions. Two of them have a common denominator and one of them does not. So if I want to get rid of the fractions altogether, I'm going to multiply each term by the LCM. What's the LCM of 8, 2, and 2? It's 8. So I'm going to multiply x over 8 times 8 over 1, negative 1/2 times 8 over 1, and negative 7/2 times 8 over 1. And what this looks like is we're putting the entire equation in parentheses and multiplying each term by 8 over 1. So x divided by 8 times 8 over 1, those 8's cancel out, leaving us just with x. Over here, 2 goes into 2 once, 2 goes into 8 4 times, so negative 1 times 4 is minus 4. And then 2 goes into 2 once, 2, whoops, sorry about that. 2 goes into 8 4 times, so I have negative 7 times 4, which is negative 28. Now it's just a one-step equation. Add the 4 to both sides, and we get x equals negative 24, which was our same solution that we got on example 11a. If you do it this way and eliminate the fractions are gone by the second step. Let's try that a couple more times just to see what you like. So take a look at example 12. Would you choose to use inverse operations or eliminate the fractions first? Since there's only one fraction, I would probably just go with using inverse operations. Cover up the variable term, subtract the constant. M divided by 2 equals 4. It's division, so we're going to use the inverse, which is to multiply. And so we have m equals 8. If there's only one fraction, straight inverse operations is probably your best bet. Take a look at example 13. Now we only have two fractions in this case, but because the eliminating fractions method is the new way, or maybe the way that is a little bit more challenging for you, we're going to do it that way. So what is the common denominator here, or the LCM? It's 5. So we're going to multiply everything in here by 5 over 1, each term. So we're going to multiply 2/5 times 5 over 1 first, then 4x times 5 over 1, and then negative 6/5 times 5 over 1. So first, the 5's divide out, leaving us just with 2. The denominator on the 4x is 1, and there's nothing to simplify, so we have 4x times 5, which is plus 20x. And then on the right here, the 5's divide out again, leaving us with negative 6. Now the fractions are gone. So now back to being just a two-step equation. Cover up the variable term, use an inverse operation to get rid of the constant, bring down that variable term, same side add and keep, divide by the coefficient of the variable. Now, negative 8/20 does not divide evenly, so we're just going to simplify that fraction. What's a common factor of 8 and 20? 4. Negative 8 divided by 4 is negative 2. 20 divided by 4 is 5. So x equals negative 2/5. Take a look at example 14. This time I have 3 different denominators and 3 fractions. So definitely eliminating the fractions would be easiest here. You don't have to do it that way, but I think it's easier. But you choose. So the LCM here is what between these 3 denominators? Right, 6. So now that we have a common denominator, or the LCM, we're going to multiply each term in these parentheses by 6 over 1. So we have 2/3 x times 6 over 1, negative 1/2 times 6 over 1, and 5/6 times 6 over 1. Work out that multiplication, then use inverse operations to solve and find your solution. Try this one. Great job today. See you next time.